The heap is a versatile data structure, and we've just seen it used for HeapSort. But you can use it for a surprising number of problems, and here's one that we'll talk about, to try to find the kth smallest element in a collection. If you had a collection of elements and you just wanted to find the smallest one, well, you could call min, the built-in function that most languages provide, and you'll find it in order n time. And that's pretty much what you'd expect. But what if you wanted to find the third smallest or the fifth smallest? If you start writing the code, before you know it, you'll probably throw your hands up and say, well, let me just sort it, and then I'll find the one at location 5. Because clearly that's a normal response. But the trouble is, that's certainly overkill. Why do I need to sort the entire collection when all I really want is to find just a particular value, which is the 5th smallest or the 10th smallest? What's interesting is I can take my heap and use it to solve this problem. Now, I'm phrasing the problem very clearly. I want to find the kth smallest element. To do that, I'm going to use the max heap that I've just described. A max heap is one where the root, or in fact any node, its value is greater than either of its two children. I'm going to show how I can use a max heap to find the kth smallest element. Here's a basic idea. I start with my initial collection, and I take k of the elements, arbitrarily, the first k elements, and I'll create a heap from those. We know how to do that because we have a build heap function that can do that for me. Once I have a heap with these k elements, for each of the other remaining elements, I just check to see if it's smaller than the root. And if it is, swap it with the root, and then heapify that structure all over again. Let's think about the intuition for why this would work. If I'm trying to find the kth smallest element, with my max heap, I start with k elements, let's say it's 3. I've got 3 elements, and because it's a max heap, that root is greater than either of its two children. So if I start to think about which is the third smallest in a heap with 3 elements, it's in fact the one that's greatest, because it's greater than the two children who are smaller than it. It's an interesting little shift there to make. Now that I know that that heap root is in fact the greatest of those first k elements, I now need to check the other n minus k elements one at a time. If any of those are in fact smaller than the root, I may have found another candidate that is in fact the kth smallest. And so I swap it out with my root and I heapify. The real trick here is reflecting on the fact that it's not a sorting process. All I'm trying to do is filter out from the potential set of possible smaller candidates and use the heap structure to clarify which one it can actually be. Let me show you the code to demonstrate how it works. I'm now going to show you how to write in Python a function that returns the kth smallest element of a collection. And it does so in an extremely efficient manner. We start with this idea that I want to create a heap of k elements, because then the root of that heap will be, at the outset, my best estimate for the kth smallest element. The way I do that is I need to create the array storage for that, and in Python I'll just take the first k elements and create a new list, so I have that, and I'll build a heap out of it. Once I've got that done, reflect on what the heap A represents. It represents a set of k numbers from the original collection, the largest of whom is at the top. And so by definition, that is your best candidate for the kth smallest element. It's bigger than all the other k-1 elements in that heap, which makes it the kth smallest. Then I'm going to go for the rest of the elements in the original collection, one by one. And if it turns out that that particular value is smaller than the root of the heap, I may have a new candidate here. That could be, in fact, the third or the kth smallest. And so I swap it in, and I replace the old one because it's no longer a candidate, and I heapify that original heap. And I repeat this process until all the elements are done. The basic idea for how efficient this operation is that usually you're given a very large collection of elements n, and the k that you're looking for is very small. You might have 1,000 data points and you just want the top 10. or you want the 10th one or the 20th one. This comes up frequently in statistics, and they call it the order function that they need. The function that you see here has a for loop, which will execute no more than n times, and within each of those, it has an opportunity to heapify, and so that would normally be a log n behavior. But look at the size of the heap over which it is heapifying. It's no more than k. So you actually have an operation that I can now say with assurance, the performance is order n log k. And if k is very small, then log of k is even smaller, and this turns out to be almost a linear operation, which after all is the ideal. Just like you can use min to compute the minimum value in just a linear time, with this function you can compute the kth smallest element in what's known as amortized linear time. It's just a small little change, and I'll demonstrate it's working here. The easiest way to do this is to just create a collection that I know any particular kth smallest value, because it just contains the numbers from 0 to 99. So if I'm looking for the kth smallest one, it's going to be k minus 1. The first smallest one is 0. The second smallest one is 1. So if I'm just going to validate that I'm trying to find the kth smallest of this collection, and I want the first one, return 0. Well, that's easy. But I can also return the kth smallest, the 10th smallest. It turns out to be 9. And if I look at how it's doing its work, I have this collection that has potentially n elements, but I've only needed the storage of size k. I'll just make a small change so you can actually see the array that's actually produced in this code. I'm just going to print it out so you can see it. If I have my collection of 10,000 values, and I want to find the kth smallest one of that collection, the 25th smallest one, this is what the heap looks like, the 25 elements. And as you can see, the root contains the maximum one of those 25 elements, which turns out to be the kth smallest. It's an extremely efficient operation from the point of view of performance. It's also extremely efficient in terms of the space that it requires. So this is just another example of finding versatile uses for these data structures that are being introduced in this course.